guys, Delaney and Elena here, and today we're going to be talking about matter because
it matters.
So, you might wonder what matter is. So, we're going to explain it here for you.
Matter is anything that has mass and it takes up space.
Today we're going to tell you the differences between atoms, elements, compounds, and mixtures.
An atom is the basic unit of all matter. It's actually the smallest form of matter. You cannot see it with your own eyes, but if you look into a high-power microscope, you can see it. In an atom, you have more tiny little particles, aka protons, which are those little things, electrons and neutrons. Now that we know about atoms, let's talk about elements.
An element is something that has one kind of atom. For example, the element hydrogen is made from atoms containing just one proton and electron. If you have very, very good eyes and could look at the atoms of a sample of hydrogen, you would notice that most of the atoms have no neutrons, some of them have one neutron, and a few of them have two neutrons. All elements are listed on a list called the periodic table of elements. Now, on to compounds.
A compound is actually sort of similar to an element, except the compound contains two or more different atoms joined. An example of a compound is water. More examples are acid and alcohol. There are also many more too.
It's a mixture. A mixture is a substance made of combining two or more different materials in such a way that no chemical reaction occurs. A mixture can usually be separated back into its original components. Some examples of mixtures are a tossed salad, salt water, and Lucky Charms. And here's a visual representation for those who didn't get it in the first round. Here on the left-hand side, we have an atom. An atom is the basic unit of matter. It's the simplest unit of matter, obviously. And on the right-hand side, we have a compound, which are two plus atoms joined. And then up below it, we also have another compound, which is two plus atoms joined, and sometimes three. This one on the bottom is three. And then over here, we have more compounds, which is like a big group of compounds joined together, just the yellow, green, and gray ones. And then on the right-hand side, we've got mixtures, which is two or plus different materials. And those are a bunch of all the atoms joined together. And yeah, that's pretty much it for all we have. And this is classifying matter. Now, on to Ethan, talking about different mixtures.
Talking about the difference between homogeneous and heterogeneous mixtures. It's actually quite easy. Homogeneous means same, which means it would be a mixture of same things. These markers are all the same color. And heterogeneous, which means a mixture of different things. These markers are not the same color. Now let's talk about the three S's. Solutions, solvents, and solutes. Solutions are when you have the outcome of a solvent and a solute. Solvents dissolve solutes. Pretty simple. And now on to Delaney and Britt with the SLGs.
Hey guys, Delaney and Britt here. Today we're going to be talking about the differences between SLGs, also known as solids, liquids, and gases.
Now you might wonder what solid, liquids, and gases are. Well, these are the main states of matter.
Yep, that's correct. Now, let's get into more detail.
Yes, well, SLGs are made up of all atoms, but their behavior is different for each state. If you have a solid, you'll know it's a solid because it's definite shape and definite volume. It will take up the place of a container or the thing that it is in.
Now, if it's a liquid, it will have no definite shape in the container, but it will have definite volume.
Now, last but not least, the G in the gas. If it is a gas, it will have no definite shape and no definite volume, just like this. Now, something along the line, they might change. A liquid can turn into a gas and then a solid, and then evaporate and turn into a gas.
Evaporation comes when the heat from the sun warms up all the groundwater, then it turns to water vapor. Condensation takes over, it goes up to the clouds. Water vapor cools down and it changes to a liquid now. Precipitation happens when the drops get big. It falls like rain, snow, sleet, and hail upon my head. I know it's the water cycle happening again. Evaporation, condensation, precipitation.
Now that's a phase change. Usually phase changes occur when adding or removing heat at a specific temperature known as the melting point or the boiling point of a substance.
Now, on to Blake talking about physical and chemical things.
Hey guys, it's Blake here. I'm here to show you the differences between physical characteristics, chemical characteristics, physical changes, and chemical changes. First, let's talk about physical and chemical characteristics. Some physical characteristics are words that describe an object, for example, smoothness, shape, weight, color, hardness, and area. Some examples are this piece of glass, which is fairly smooth, and this rock, which is fairly rough. Okay. Some examples of chemical characteristics are flammability and heat combustion. Just like how if you hold a match up to a piece of paper, it'll catch on fire. Like, you can't see it out here in this bright sunlight, but you can clearly see that it's burning in some spots. Like how it's turning into a different characteristic. So that's chemical characteristics. Yes. If something is physical, it does not change the identity of matter or the shape, just like how Coke and Mentos. So it should work. It is working. I just can't see it. Just if something is chemical, the change in which matter changes into a new substance, like baking soda and vinegar. You can see that it is changing in heat. This is getting pretty warm. And that sums it up for physical and chemical characteristics and changes.
3. Thanks for watching the video! Okay, come here.
There's no whipping.
Come here.
No, stop, seriously.
And I don't know.